So now in today we'll be building a smart contract so that we can practice more on what we have learned in the previous lessons. So now today we'll be building a smart contract that is called Fund Me. So the goal of the smart contract is to enable funders contribute money for a particular project or cause. So that is basically what the smart contract is for. So the core functionality of the smart contract is the smart contract will enable funders to be able to contribute to a particular cause. Then for the withdraw functionality, only the owner of the smart contract will be allowed to withdraw contributed funds to for only the owner of the smart contract that will be allowed to withdraw the contributed funds. Then the way in which the funds functionality work is there's a minimum amount that is allowed to be contributed. So now let me go ahead to my remix and write the problem statement. So yes, so my remix is still loading. Now let's create another solid file and name it fund, name it contribute.sql. So and for after creating a solidity file, before we start writing anything, there are two things we usually do. That is specifying the license and specifying the solidity version we want to use. So now to specify the license, we use the syntax is the comment symbol, then SPDS followed by the word license, then followed by identifier, then put what is the name of our license. The name of our license is MIT. Now we need to specify the solidity version. We with the help of this pragma solidity keyword, we are able to tell solidity that we are specifying the solidity version we're interested in. Then with the help of our caret symbol which tells solidity that we are only interested in solidity version that is starting from 0.8.0. Now let's move ahead to create our contract. The help of the contract keyword and let's name it contribute. Now we'll be able to create a just empty smart contract for now. So now before we go further in writing our code to create this smart contract, first I would like to list out the problem statement. So now uh, which will be stored in a comment. So now, what is the name of the smart contract? We are creating a contribute smart contract. So the core functionality is ability to withdraw. So ability to withdraw only only the owner only the owner is allowed to withdraw the contributed funds. So this is how the withdraw functionality works. So withdraw functionality. Then let's move ahead to write the fund functionality. Fund functionality only the um $50 is the minimum amount allowed to be contributed. Now let's create a skeleton of how this smart contract will look like. So now first we want to create a variable to help us store the minimum amount we are allowed to contribute. or the minimum allowed amount a funder is allowed to contribute. So now we are creating a Unity 56 variable, then public, and let's say minimum, let's name it minimum amount allowed, which will be 100 USD. Then let's create the withdraw function public. Then let's create a fund function, and then public. So now we've been able to carve out a skeleton for the smart contract we want to use in for the contribute. We've been able to carve out a skeleton for the contribute smart contract. Now I want to draw attention to some important from I want to draw attention to a visible problem here. Now the minimum amount we want the funders to contribute is 100 USD. But currently, we are in the blockchain environment. We are in the blockchain environment. The only currency we have access to is basically the native currency of the blockchain. And for Ethereum, since we are currently working in the Ethereum ecosystem, the native currency on the Ethereum blockchain is Ether. So now, since USD is absent in the Ethereum blockchain, then one way or the other, we need to look for a way of converting this 100 USD into its equivalent value in Ether. So now the question arises, how do we convert? Because for us to be able to convert this 100 USD to its equivalent value in Ether, we need to know the amount, we need to know how many USD will be equal to $1, or we need to be aware of $1 is equal to how many ether. So this information is very useful so that we'll be able to convert this 100 USD to its ether equivalent. Now, where the challenge is, even we're in the normal Web2 environment, we can just make a request to an external API to get how many USD is equal to one ether, so that to help us handle our conversion. But now we're in a blockchain environment. A blockchain in when in The blockchain is not allowed to interact with the external world. That is, in the blockchain, you can't make a fetch request to an external server. You can't fetch information from an external server. The blockchain is built like this for a purpose. And the reason why the blockchain is built like this for a purpose is that so that the blockchain will be able to achieve consensus. Now, in our introductory lesson, we said the blockchain consists of a network of computer, and each of dis network of computer they must reach a consensus. So that is, when I say they must reach a consensus, that is, each and every node forming dis blockchain network, they must have all their state must be the same, their state must be uniform. So now imagine a case where each of these node forming this blockchain network, they are making a request to different server to get different information. A case where node A is making a request to get the names of footballer, node B is making a request to get all the women in a particular class, and node C is making a request to get the latest information. So each of these nodes forming the blockchain network, they will end up having different states. And this is not how the blockchain and this is not how we want the blockchain to work. In the blockchain, each and every of these nodes must have the same state. So that is why the blockchain was built like this. So the blockchain was built like this intentionally, so that all the nodes forming this blockchain network must have the same state. Now, the challenge that arise from this is that still we want to build a smart contract that we need value from the outside world, that is, that we need off-chain data. So now when I say off-chain data are data that are not available on the blockchain, while on-chain data are data that are available on the blockchain. So on-chain and off-chain. Still, we are building a smart contract where we still need this data from the outside world. How do we handle this? Then a solution was built, which is called what? Blockchain Oracle. So now blockchain Oracle was built so that to give us the opportunity to what? Get a data from the outside world. You can see a oracle, a blockchain oracle, as a middleman between the blockchain and the outside world. So now a blockchain oracle is a third party service, or a blockchain oracle is a solution that enables us to get off chain data and bring that off-chain data and bring it to the world, to the blockchain, so that we can use it in our smart contract where we need all these off-chain data. So that was why this blockchain oracle was produced. So this is the solution. It help us to this is the solution. This is the so it help us to solve the problem of getting off-chain data. Now this off-chain data can also be categorized based on this off-chain data. They can also be categorized based on how they work. Like now, sorry, I mean this blockchain oracle can be categorized based on how they work. Now we have the inbound and outbound oracle. Blockchain oracle that fall into this category, they basically help us bring the data from the outside world and bring it to the blockchain, or they are oracle that take data from the blockchain and take it to the outside world. But majority of the oracle that fall under this category, they are basically oracle that bring data that bring off chain that bring data from the outside world into the blockchain so that we can use it in our smart contract. So now we also have different categories here. So I will be sharing this slide immediately I'm done with this tutorial. So it is quite easy to understand when you read through it. So to avoid wasting our time, that's we'll move further to the next thing. So now, example of this blockchain oracle, we have the band protocol and we have Chainlink. So now we're actually interested in Chainlink. You can read more about the Bandlink protocol. So Chainlink is a blockchain oracle that help us bring off-chain data that are needed in our smart contracts. Chainlink is a blockchain oracle that help us bring off-chain data that are needed in our smart contract. So now another challenge comes is why now if the blockchain is giving us decentralization and taking away centralization, then we need to be careful of the kind of oracles we are using. There are some oracle that basically fall under the central under there are some oracle that basically fetch data from just one central server that is owned by one entity. So now for this kind of oracle, they are basically reintroducing the problem the blockchain is trying to solve. Because because now if the blockchain is taking away centralization and giving us decentralization, we then go ahead to use an oracle that basically fetch data from just one server that is owned and controlled by one entity. Then some issues, so that kind of server can be manipulated, which can cause a lot of hard work on the blockchain. So that is why this now leads to the need for a decentralized oracle. So now a decentralized oracle was now built like Chainlink. So the way Chainlink works is Chainlink fetch data from different sources, not just from one server. Chainlink fetch data from different sources. Then all these data that are fetched from different sources, then they are now stored in a bucket. Then the aggregation of all the data that was retrieved from these different sources will now get a final value from all this data. So this is how basically how Chainlink work. Now let's go to the Chainlink official website. So this is the Chainlink official website. Now the Chainlink offer a wide array of products to enable us build a more efficient and powerful smart contract. But for this tutorial, the Chainlink product we are interested in is the market and data feeds. So the market and data feeds. So now in our smart contract, we need to look for a way of getting how many USD will be equal to 1 ether. So now that is why we are making use of this Chainlink data feed, because it helps us to get the rate of a particular token pair. So now let's now go back to our slides. So now Chainlink price feed. So the Chainlink price feed is one of Chainlink products. It basically enables us to get rates for a specific token pair. So now when you say Chainlink price feed are basically smart contracts that get updated periodically by a nodes of network. So now this Chainlink, so it is this Chainlink price feed we are then going to interact with in our smart contract, so that we'll be able to what to obtain this off-chain data that is needed for our development. So now I'm sure that with what I just said, a kind of confusion is bound to set in, because we said it is not possible for us to interact with the external world when we are in a blockchain environment. Then how is Chainlink able to come up with a smart contract that is able to interact with the external world? Now, let me clear your confusion. So now, the way this Chainlink works is that a nodes of network, they are set up. So the core function, the sole aim of setting up this network is to what? To update this Chainlink price feed smart contract, so that they will have the latest data. So now after Chainlink set up this node of network, and their core functionality is to what? Is to update this price feed smart contract, so that they will have the latest value. Then each and every node forming this network, in which their sole aim is to update the Chainlink price feed smart contract, each and every one of this node will fetch data from different sources. Then after they fetch data from different sources, then the data is then submitted. Then with all the data that is submitted, a final value of that particular token pair is then reached. So now in this case now, the final value which is reached is which was reached is now $400. While you see these various nodes, some nodes submitted $399, $401, $398, $402. So now with all this, then a final value is then reached. So now after a final value is then reached, then one of the node that is forming this Chainlink network is then selected to verify the final value reached. Then the signature of this node is then added. So now it is still the same node that is selected to verify this final value reach. They are now the one charged with the responsibility of what? Updating the Chainlink price feed smart contract, so that anytime we are now interacting with this price feed, we are confident that the value that is returned from this price feed is the latest value. Now, why is it that the signature of the node that verify this final value reach why is it that the signature is being obtained? The reason why the signature is obtained is that, so in a case where this node wants to carry out want to game the system or want to do something harmful to the blockchain, then if this kind of activities are detected, and then it is with the help of the signature we are able to know which of the node is doing such an harmful activity. Then with this we are able to kick out the node from the network, and they will not be able to gain or make money from the network again. So now let's go to Chainlink and let's just look at the Chainlink price feed. Now click on this price feed. As I said, the Chainlink price feed, they are basically smart contracts in which we interact with, so that we can get all the off-chain data that are needed in our smart contract. So now click on Chainlink price feed and explore Chainlink price feed. If you see, each and every one of these pair are managed by a specific smart contract. So now, if you want to get the Ether USD rate, all you just need to do is call the just interact with the smart contract that is in charge for this particular pair. Call the smart contract. Then there's a function there in which will give you what the rate of this specific of in which the rate in which this currency pair is. So now let's go to the price feed document. Okay, let's go to the documentation and let's look at this the price feed smart contract. So now let's go to contract addresses. So now if you see on the Ethereum mainnet, this is the contract address in which we interact with if we want to get the 1 inch Ether token pair value. If we want to get their rate, this is the smart contract we will interact with. So these are the various Chainlink price feed smart contracts that enables us to get the rate of a particular token pair. Now for the Goerli testnet, these are the smart contract that have been deployed to the Goerli testnet, so that we'll be able to obtain the rate of a specific token pair. Now, in our own case now, we are interested in getting the Ether USD. So this is the smart contract we are going to interact with. Now, I've been able to walk us through looking at what blockchain oracle is, why this oracle is needed, and all that. So I think for this lecture, this is where we stop today. Have a wonderful day.